All right, let's talk about a really cool but kind of tricky puzzle in programming. A list that looks like it never ends. It's called a circular linked list. And today, we're going to figure out exactly how to navigate it without getting trapped.
So that's the big question, isn't it? If a list literally has no end, how are you supposed to read all the items on it without just going in circles forever? That is the core problem we are going to solve right now. Okay, so to figure out how to escape this endless loop, we first have to understand how the thing is even built. So let's start with a structure you're probably already familiar with.
Think of a standard linked list like a train, Each car is a node that's connected to the next one. And the very last car, the caboose, well, it's attached to nothing. That's your null pointer. It's a clear, unmistakable sign that says, hey, the ride's over. This is the end.
Now this is where things get really interesting. Look at this tiny but super powerful change. On the left, you've got the standard list stopping cold at null. But on the right, our circular list, well, it doesn't stop. That last node points right back to the very first node, the head. It's like taking the caboose and hooking it right back up to the engine. And that one little change is the start of our whole problem. Yeah, that one simple tweak pointing the last node back to the first creates this massive challenge. It basically sets a trap for any program that isn't paying attention. We're talking about the dreaded infinite loop.
I mean, this is how you'd normally do it, right? Just keep moving down the list until you hit that null at the end. It seems totally logical. So what happens when we try to apply that same logic to our new circular structure?
Well, here's the kicker. The pointer will never be null. There is no null to find. So our poor program gets stuck on a hamster wheel, chasing its own tail, printing the list over and over and over again. It's completely, totally trapped. So how in the world do we get out of this mess? What we need is a map, a precise algorithm that lets us walk the circle exactly once and know precisely when we're done. So let's break down how it works. The real secret sauce here is in steps 2 and 5, using a do-while loop. This is so important. It lets us process that first node before we even start checking our condition. From there, we just move our pointer, print the data, and keep looping until our pointer lands back on the head again. That's our signal. We've made one full lap, and it's time to get off the ride. All right, theory is great, but let's see what this actually looks like in practice. We'll pop open a simple implementation using the C programming language. Okay, first up, we have our basic building block, the node itself. It's super simple, right? It just holds a piece of data, in this case just a number, and crucially, a pointer that tells us where the very next node is. And boom, here is our algorithm in action. See how that logic we just talked about translates perfectly? We do two things. Print the data where our pointer currently is, then we move that pointer to the next node. And we keep doing this while our temporary pointer has not yet made it all the way back to the head. It's clean, it's elegant, and most importantly, no more infinite loop. So we did it. We've navigated the endless list. Let's just do a super quick recap of the big ideas that got us through this. So here's the bottom line. The circular structure itself creates the trap. A standard while loop gets completely stuck on that hamster wheel. But the do while loop, that's the key that unlocks the whole thing, letting us visit every single node exactly once before we stop. And that, right there, is how you solve the endless list puzzle. So there you have it. We figured out how to safely traverse a data structure that, at first glance, seems like it goes on forever. But, the journey never really stops. So here's a new puzzle for you to chew on. Now that you know how to read the list, how would you safely break that circle to insert a brand new node? Thanks for joining me on this one. I'll catch you in the next explainer.